Um, last time we started a new project. That was all about, well, a salary contract that yeah, pays, or that describes a relationship between a, well, or can describe a relationship between a employee and an employer in kind of an anonymous setup, like like in the real world, there is some there are obligations each of the parties has to abide by, but in an anonymous setup, your employee or your employer can just run away, and this contract creates some sort of a risk or guarantees that yeah, guarantees for the employee that he will get paid for a certain amount of time. So let's get back into it. There's probably other scenarios you can use this, but yeah, this is the one that is kind of prominent, I guess. All right, last time we stopped right in the middle of everything. What is it called? Prep vesting TS. This is the test. And we had right. We stopped at I think we just wrote tests from the creation to the first transfer. So we stopped when we had our employer, in this case, so the owner of the contract. I guess it's the owner, is it? Or in this case, it's the owner address, and the other account is the employee or the receiver. Right, so should deposit some amount. Amount is 1 ether. The owner implicitly deposits one ether, and we are just checking that the counters we implemented or we added deposited amount. So this is the current amount that is in the contract. The amount that was deposited over the lifetime of the contract, and we're testing that the test token we created actually shows the same amount in the contract. Okay, so how does it look like in what? Oh, we need to rename this one here. It is perpetual vesting. Please. Okay, I guess we need to clean up that this yeah, the workspace kind of artifacts, cache. Don't need node modules, type chains. Yeah, I guess we can delete that. Should create a package JSON script for that, but let's not do that for now. Let's keep it simple. So if we run the test again, it should compile first. All right. Okay. So yeah, we created a bunch of empty methods for now. And the deposit function does not require the depositor to actually be the sender. So we capture the sender and the receiver, so the employer and the employee in this case here. But it doesn't matter who actually deposits into this account. It just matters that a sender is able to actually withdraw later in case he or she doesn't want to continue this contract. And the receiver down here has to be the one who is, or the only one who's able to to claim his payout. Oh, let me just check on something. All right. Okay, so the question is, do we need to do more here? We could define events for our deposit function down here, but I actually did forget. Syntax. Look. Events. Right. Yeah, so we can define an event here and we emit it like that. All right. So event posited, and we want a index or check. We want an address which is indexed sender or depositor, and we want a uint amount. That should be enough, and emit posited message sender, and let's see. This doesn't fail, right? Next question is, how do we actually capture that event in a test? So let's have a look at the log example we got with the example project. I think there was an example in here. Mid lock withdraw args lock amount locked amount. What is locked amount? Let's have a look at the actual lock contract. So it emits a withdrawal with a balance and a timestamp. and any value. Does any value come from up here? Okay. That should be easy enough. Question is, how can we... Or wait, we can expect that here. Expect await. To emit. Posited. Then with args. Okay, the args are owner.address and the amount. So amount should work. Contract name, event name. Okay. Let's see, does that work? Okay. That was easy. Yeah. What next? I'm just curious, since I haven't actually checked this implementation out. Let's have a look at the safe transfer from. Do we need to check for a return value? I think we don't have to, because that is the more or less the reason why we're using this. But let's have a look anyway. So we need to look into the OpenZeppelin contract. Probably in util. No, in has been token ERC20 util. Yeah, here. Save ERC20. So safe transfer from does not return anything. Call optional return. And yeah, it does. To perform a low-level call here to bypass Solidity's return database checking mechanism. Since we're implementing it ourselves, we use function call to perform this call, which verifies that the target address contains contract code, and also asserts for success